So let's get started. My plan for today is to get through the latest news about the hackathon preparation, but from the list that I see, a lot of people already pretty advanced, should be pretty advanced on the preparation side. But let's go quickly through the latest sort of news, and then I will be open for questions. So let's start sharing the screen. All right, so the idea from us is that the main place where you share the information about where we share the information about the hackathon is the EERIE Hackathon GitHub page. And we will try to get the README of this GitHub repository updated and with the latest information. So right now I will just go through this README more or less like through each of the items one by one. And if you have any questions on the way, just don't hesitate to ask. So first of all, the data section, most of the EERIE simulations are still in progress, but we already have some of the simulations available. But for some of the models, we only have examples that are based on results from other projects. But that should be enough for you to get started and to get comfortable with, for example, unstructured mesh data, if this is something that you are dealing with for the first time. So we have compiled also the list of variables that we aim to make available. And most of them are, well, I mean, the ones that we try to make available for sure will be interpolated to quarter-degree grid. And that's this in this spreadsheet, this EERIE part. So that's the list. And this is something that you should be able to rely upon in planning your activities and in working groups. But there is an also extended list where we try to actually deliver more variables, but that's let's say not guaranteed. Although for from some of the projects, for some of the models, those variables are already available, but it's not guaranteed that for all of the models we will have them. Then let's go down. So the data structure. So the data will be available through catalogs, and we're still working on the ways how to make the working with catalogs easier for the users. But in general, for example, for DKRZ, here's a very simple example of how the things will look like in terms of accessing the data. Of course, I mean, it's really not that easy to remember all of this kind of a path. So we will provide tools to, first of all, to discover where different simulations are. And another thing is that we put together some example of how to work with the catalogs, especially how to search for different variables in these catalogs. And I can show you how it works in practice. So we have a little library here that you don't have to install. It will be part of the EERIE Hackathon repository. So if you check it out, then you will have it available by default. And then you open this link to the catalog. Again, don't panic if you don't understand exactly what is going on. We will try to provide examples, and for each of the models, we will actually have example that will show you how to access the data from this particular model, so that at least at the starting point, you should be fine. And then let's say we want to see, like, in this whole EERIE project, what are the variables or simulations or subdivisions of the simulations? Because I mean, you have here you can have like so the catalogs have some specific structure, and you can have here an icon, and icon can have EERIE control simulation, and there is a some other simulations, probably, yeah, EERIE spin-up simulation, and in the EERIE control simulation there is atmospheric part, and in the atmosphere there is interpolated data and native data, and in interpolated data there are two D monthly means. Again, sounds a little bit like too much, although for people who get used to CMIP6 data, it might be not that surprising, this structure. But at the end of the day, well, I mean, it will make sense after a couple of hours of working with that. But it always was a problem to search for some specific variables if you don't know exactly what you are trying to get. And this is the thing that we try to solve here. It's specifically flow, actually create a function that allow you to search, for example, for ice and all the catalogs, and the execution would look like this. So just go through the whole catalog and try to find the places where the ice is mentioned in the long description of the variables. Of course, if you know already that you want to search in the only for icon models, so you can make the catalog path shorter and search for temperature in this case, and it will be much faster. But then when you find some place in here that you want to kind of some data set, let's say, that you would like to open. So you, for example, you find out that there is a temperature, 2-meter temperature in 2D monthly mean. Where is it? 2D monthly mean here. I don't want to have it in native. I want to have it interpolated here, right? So we were working with icon model. We would like to look at the atmosphere, interpolated data, and 2D monthly mean interpolated data. So you open it like that. Again, a little bit elaborate syntaxes, but I think that's something that we get used to. If not, we can also change it. So it depends on how things will go on the hackathon. Then you open the data, and here is your XRA dataset that will have all the data variables from this 2D monthly mean dataset. So they are listed here, but you're of course only interested in the temperature. You can plot it, and so here is your quarter-degree interpolated temperature. We'll try to make this search catalogs notebook a little bit more kind of explanatory. Right now, I just explained it by myself. I will try to put some more text in here, but hopefully it's something that will help you to navigate through the data a little bit easier. Okay, that's the thing that was linked from here. Then the status of the simulations. IFS FESM have two types of simulations available right now for the EERIE hackathon. One is the test data, and that's an XGEMS 3 cycle 3 simulations. Here is the description to the simulations. And the second one is EERIE simulations that are coming. Right now we only have 2 years, but by the beginning of hackathon we hope to have something like about 10 years of simulations, and that's a TCO 1279 and G5, which is basically atmosphere at 10 kilometer resolution and ocean at 5 to 13 kilometer resolution. Here I put a little helper of how to find the simulation itself, but again, I'll try to make it a little bit more obvious. And like if people actually have ideas of how to make things easier to grasp for the newcomers, and you're welcome to suggest things. Okay, where we are. So NextGem Cycle 3 simulations, they have a little bit higher, well, not little bit, it's actually 5 kilometer resolution simulation in the atmosphere, which make it even more fun for the atmospheric people to work with. So the icon data is, well, there are test data for cycle 2 simulate from cycle 2 NextGem simulations, but EERIE simulations are also pretty much on the way. So I actually am not sure if it's like both 10 kilometer ocean atmosphere. I think the ocean is 5 kilometer, right? Dion, correct me if I'm wrong.
Yeah, 5-kilometer ocean, 10-kilometer atmosphere, we have more than 21 years now.
Yeah, it's there is a lot, and I think you also don't have only not only control but also a spin up. So spin up is another
52 years of spin up.
Okay, so it's and 52 years of spin up. So quite a big chunk of data from like EERIE simulation data from Mike group. So IFS NEMO from BSc, I haven't heard anything, unfortunately. So hope that they are getting there. And I think they were contacting Fabi at some point that they want to copy the data. NEMO is also pretty far with what they have already simulated, but their data allocate on Jasmine, and it's a little bit different way to assess the data, but it's all also described, and there are some examples that I will show, kind of point you towards later on. IFS only, it's AMIP simulations, and there are, well, I mean, 10 years of 10 years here, and I think it's also 10 years next gen cycle simulation. So they actually differ in the, as far as I understood, by the well, by the configuration that was used to run the simulations, and they will also be available through the catalogs. So right now they are just located in some place somewhere, but they will be incorporated into the common catalog structure. There is also, like, I mean, good thing I think is the observations are also available, so you can go to the observation folder here in the EERIE catalog. Yeah, so it's EERIE Hackathon 2023 observations. So again, if you start from the beginning, that's an observation folder. And here in the README, you can see what kind of observations are available. And the cool thing about it is that, well, I mean, for each of the observational data set, there is a notebook that shows you how to actually open it and work with it. And I will double check if they work with the new structure of the catalogs, but I think it should work. So it just shows you how to open the thing, and basically it goes usually down to the plot. Right. So what you need to get started, please make sure before the hackathon starts, basically today, the latest is that you have a DKRZ account, and that this DKRZ account is actually accepted by the DKRZ, and that you have also a Jasmine account. So in order to work with both IFS FESM, ICANN, NEMO, and IFS NEMO data and IFS, well, I mean, I think IFS decided at the end to do it on DKRZ. But you still need a Jasmine account. So you need Jasmine and DKRZ account. Without this, I mean, it might take some time. So it would be very sad if you just sitting on the hackathon without, well, I mean, without possibility to do anything, because we don't have any local data for you to play with. There is also Science Hour with me describing this repo before. And there is also an ESGF portal usage from Pablo. So how to get started? I mean, I think that the good starting point is this notebook about how to work with unstructured meshes, what's the unstructured meshes and how to work with them, because I mean, I think most of us know how to work with structured meshes, so NEMO should not be a problem for most of us, but unstructured grids might cause some questions. So I would go through this notebook and try to repeat the things that are happening here. There is some examples of interpolation to regular grid. Right now it's from PESM, but I think we will add a couple of more for other models as well. There is some work in progress on like unified interpolation, let's say, and there is also for when you work with large amounts of data, you better be doing this in parallel exploring parallelism that is available for you on HPC. And there is a FASM example of how to work with Dusk and model data, but should work for any model. So there is a growing list of examples for individual models as well. And each of the models, I think almost all of them right now, have something that is called Start Here. For example, for Nemo, again, so the structure of the hackathon folder, repositories that you have this commons, which contains the notebooks that are common for all of the models, and you have different models. And if you go, for example, to Nemo, and you go to Nemo, so you want to work with Nemo data, there will be a Start Here Jupyter notebook, and that's we try to keep it for all the models, and so at least 5 examples are now available for you how to start with the data on different ones. And then there are different examples of different things. So again, regrading to regular grids, plotting global and regional maps, effective parallel aggregation, plot transect. Actually, icon example is also here. I will have to put it. And how to compute AMOC is also available for icon and Nemo. So you can browse through these notebooks already and try to figure out what you want to, try to play around with the data and get used to it before the hackathon. So that's the similar standard variables that we have. There are some useful external resources and in a way how to contribute to the to this repository and some documentation of the models. So I think with that, that's the kind of general description of what is going on right now. Now I can show you a couple of examples what have been added lately. I think the observational ones is something that is worth looking at. And then for FASM and now for icon as well. So Fraser actually ported to icon. We have a couple of interesting examples that show you how to interpolate data and plot maps on different projections. And that exploits this little library that we put together in the same repository. It's not something that you have to install, but that help you to, in this case, helps you to select the region out of unstructured data or structured for that matter. So we try to make it in a way that it works for both unstructured and unstructured data. So some helper functions that would work for both, not specific to some model. And you select you select the region, and then you interpolate the data to this region in a pretty efficient way. So it's nearest neighbor interpolation that saves the indices that you need, and then you can do it for any projection, right? So this is a Mercator projection. You can do it for North Pole stereo projection, and that is that you can at the end have an animation of the sea ice, and I think I have it here. So very quickly you can have, it's not MLD, it's CS thickness, but you can have in the CS. Okay, it's only 10 time steps. Let me try to see. Find the longer one. So this is a 365 days of the CS, right? So and then that took me about half an hour to create. So that's just an etcdf file that is interpolated to the polar North Pole stereographic projection, but it's kind of giving you daily CIS data from FASM, and you can do whatever you get used to do with NCU, and of course you can work with with CDO with this data. And another example that also kind of tries to embrace this philosophy that we can work with all ocean models, at least for some things. Of course, not for all the things, but some things can be done in the same way. Is this example of how to plot the transect? So you select the transect across here, and you can plot it, and then you can save, like you can save every day. You can extract the data for every day. You can save it, and that's what you basically get at the end. And see view. This one. So that's the transect of temperature. I mean, the vertical profile is completely screwed up, but if you move it like this, so like I mean, I'm showing you also in hope that it's not only the means that you will try to kind of look at this data, but you also will try to look at the daily and maybe sometimes hourly fields. So that's the temperature that you can see in this transect, and you see that a lot of eddies and meander from the Gulf Stream are coming and going, and there is effects of this eddies and meanders on the bottom temperature clearly visible. So there's a lot of interesting things happening while this during this year, and it's not like analysis of this data doesn't really comes down to just analyzing the mean value. So there is a lot of interesting dynamics that people can look at. So that's well, I mean, that's basically it. That's all that I wanted to say. Do you have any questions or comments or wishes before the hackathon? I mean, we are working pretty hard on making this thing work better for the hackathon. I mean, I think it's now half-baked, all the things, but hopefully by the time of the hackathon, it will be in much better shape. But you actually can help us to put this in a better shape, because with your input and with your notebooks and example notebooks, if you have some, we will make it better and easier to work with for everybody. All right. So any questions, comments? Yeah, well, I mean, everything is very clear. And yeah, if there is nothing to comment or ask, then see you on Monday General Assembly, and then on Wednesday on the hackathon. Marie.
Hello. Thank you. I have a question. I mean, is there going to be three-dimensional temperature and salinity available from models?
Yeah, right now, right now, what we have from FESM is NextGEM's data is 5 years of daily 3D temperature salinity and UVW. So that's something that one can work with, but I think Diane has more data for you.
So Anne-Marie, we really took care of that for you and Jen, the request. So NextGen has 5 years, 3D daily ocean output. Icon ESM has 10 years daily, full 3D temperature salinity UVW. I hope that's enough data to play with for the hackathon at least.
This looks more than enough. I mean, I was thinking that we would have rather monthly.
No, we took care. We really heard what you requested for, and we pushed for it. So there is 10 years now.
Okay. In fact, I have not really planned things to do with it. So I mean, I need perhaps to ask again, Jing Song.
But yes, so there is data to play with, full 3D ocean, and it even has, for the whole 20 years that we have, well, the surface variables, we have it every day. So it's only the first 10 years now for the ocean, because it's already a lot of data. And then the rest, the subsequent years has the cross product terms, if you want, on monthly timescales. But I figured that 10 years is enough to play with for now. And if you guys really need more, then we can discuss more for subsequent ones.
Yeah, I mean, it really depends on which questions to ask. I mean, I will go back to Jing Song. And yeah, when you say you have 10 years, this is starting in 1950, that's it?
Yeah, it's the control run.
Okay, so it's...
We don't have any historical yet.
Okay.
It's, sorry, we're a little bit behind on that.
Okay, okay. Yeah, I will ask Jing Song. I mean, so far I was just planning to work on the analyzing Sisyphus 8 and contribution from temperature and salinity to Sisyphus 8 with a PhD student who is coming with me. And I was thinking that there would be monthly output from the ocean.
Yes, there will be. There are monthly outputs.
Yeah, but I thought there would be some from the Met Office, but of course then, I mean, we can also use CMIP one, right? If
Met Office also has a lot of outputs.
Yeah, I think it has
50 years.
Yeah.
They have 50 years of output.
Okay.
But you will have to work on a different machine for that.
Yeah.
Yeah. So that would be on Jasmine, right?
Yes.
Okay. Yeah, the student has an account on Jasmine. I mean, he just started. I thought he would be here today, by the way, but he's not. He has an account on Jasmine. I didn't ask him to get an account on DKRZ yet because it just started 1 month ago. So I mean, it's very. I mean, it will be a bit difficult for him to be there to learn too many things at the same time. We'll see.
Well, I mean, it doesn't hurt to have an account on the Karazat anyway, so it's not that difficult to apply for it. And I think it would be beneficial if he could do that, or she.
Well, I mean, I sent him an email then.
Because I mean, all of our data, especially high frequency data, will be on the Karazat. So, yeah. All right. Any more questions? Well, if not,
I have a question.
You do have a question.
They asked.
That's a bad sign.
Oh no! Oh no! Actually, now I'm trying to remember what was the question. Oh shoot! I already forgot myself. Yes, you said Nereus would be set as a default within
No, it's just a again, it's simply a folder in the repository. So if you check out the repository, you get it. And so like the way how it's done, you just add the system path like two levels above to your import path and then in the import. Again, it's just basically one big script.
Okay.
One big file with some functions, and that's in order not to put these functions in the Jupyter notebooks.
Right.
We just put them into some other place, and I don't want to make it a hassle of installing it. So it's
right. So we have a path or we have a folder and a link to that folder so that we can use the functions of that in the Jupyter notebook.
Yeah. So look, that's basically how it's done here.
That's awesome. Okay.
So you just have import sys, you add the sys path like okay 2 levels above, and 2 levels above is now inside of your system path, and then you say, okay, import Nereus, and Nereus is actually located to kind of levels above. I mean, if you would have the Jupyter notebook not at the IFS FASM/FASM, but just in IFS FASM, you would need to add only one level above, right? So basically, you have to provide the path towards the place where this little folder is located, and that's it. Make sense?
Okay, so we actually have to download the whole branch.
Well, I mean, yeah,
On Levante, right?
Yeah, it's like, I mean, yeah, it's best to, the best thing is to clone the whole EERIE Hackathon
right. Okay.
thing and then work from there. That's what I usually do.
So we all should clone this in our individual home accounts, home folders.
Should is a little bit of stronger word, but yeah.
It would be preferred if we do it,
Yeah,
if we want things to run
so
smoothly.
the easiest way is to clone this thing, yes.
Okay.
And maybe that's something that I actually have to add to the description.
Okay.
Yeah, and maybe one last reminder: we only have now 2 submissions to the for the image contest. So you still have chance to win some goodies, and just send an email with a figure to me, or figure or animation or whatever. And there are some pretty cool things that Matthias, for example, presented, and MPI as well. So yeah, so worth a try. All right. So any more questions, comments? Yeah, don't forget that we have a MetaMost channel for the support, and ask questions also there. Try out things, try to break things, tell us what doesn't work, and we will try to fix it. And there will be a lot of things that doesn't work. So, but if you find them, don't just swear at us. Also, let us know, and we will try to fix the stuff. Right? Okay.
Sounds good.
Yeah. Then see you next week. Bye bye.
Thanks, Nikolay.
See you.